Number 5. Here we're looking for pressure. Pressure is force divided by area. The force exerted is going to be equal to the weight of the person. The weight of the person is just mg, or the mass is 79 kilograms. And the area is going to be the length times the width of the foot. So make sure to convert the length and the width in meters, and we'll have the area is equal to 0.13 times 0.28, which is 0.0364 meters squared. Plug that in for the area, and mg, I got 21,269 pascals, which is rounded to 2.1 times 10 to the 4. Number 6. So this one is asking for how thick must this oil layer be for the gauge pressure here to be 8.5 times 10 to the 4 pascals. Now, gauge pressure, unfortunately I forgot to say what that means. I wish this had just been pressure here, but this problem has gauge pressure. Gauge pressure is just the pressure here, not taking into account the pressure due to the atmosphere. So usually when you're trying to find the pressure at the bottom of a layer, you would go pressure is equal, pressure at the bottom equals the pressure at the top, which is usually the atmosphere right here, right? Pressure of the atmosphere, plus rho GH. And that would give us the pressure here, for example. But gauge pressure means we don't care about atmospheric pressure, and we just care about the pressure due to that layer. So that's what that means. So to find the way you're going to set this up is the gauge pressure at the bottom is going to be due to both of these layers. So it's going to be equal to rho GH for the oil plus rho GH for the water. Remember that the rho GH, what that stands for is it stands for the pressure due to the weight of the layer of that liquid. So what we're going to do next is just plug in the numbers. The pressure here at the bottom is given to us right here. That's P. Rho of the oil is right here, 450. And then the layer of oil, that's what we're looking for. That's what we're going to be solving for. H of the oil equals P minus rho GH of the water divided by rho of the oil times G. So let's finish defining our variables. We have rho of the water, which is right here, G, and then height of the water is right here. So plug in all of those numbers in here for the layer of the oil, and I got 12.6 meters, which rounds up to 13 meters. And then the other pressure problem here has to do with Pascal's principle. So when you see one like this, you just want to imagine that you have a small piston and a large piston. And you're going to apply some force here, and you're going to get some bigger force out here because you have the bigger area. So we always set these up as F1 over A1 equals F2 over A2, where F1 is here and the A1 is here, F2 is here. So what we're given is the radius of each piston, so make sure to get the area. So assuming that the piston is circular, the area 1 is going to be pi r squared, and this will be R1. Make sure to convert the radius to meters, so R1 should be 0.05 meters. And then R2 is going to be 0.15 meters. Area 2 will be pi R2 squared. Plug that in. And then F2 is given. It's going to be 20,000 newtons. And then we're trying to solve for F1. So F1 will be equal to F2 times A1 over A2. Plug in the numbers over here, and I got 2222 newtons, which rounds to answer choice A.